Good evening, ladies and gentlemen. My name is Princess Masondo, and welcome to today's session where we will be looking at developing a data analysis plan. I am from the College of Graduate Studies. I'm based in the School of Interdisciplinary Research and Graduate Studies, and I will be taking you through today's session. So without any waste of time, I'm going to start with the presentation. Thank you. So as I've already indicated, we'll be looking at developing a data analysis plan. Okay, so I'll just lay a foundation and we will look briefly into measurement as scales of measurement, and then we'll go into different kinds of data analysis, but integrating them to developing a data analysis plan. So what is the purpose of a data analysis plan? It's a document that you develop as a researcher, and you develop the document in advance while you are busy with your proposal. Once you have finalized the main objective of your study, and you've also outlined the specific objectives or the specific research questions, then you can use that to develop a plan, which is like a map of how you intend to analyze the variables, the data that is collected through the variables. We know that failure to plan is planning to fail. And when you plan, you bring the future into the present. And that is the essence of developing a data plan, is for you to ensure that at a planning stage of your study, you can already have an idea, a preview of what to expect. So it's like you have an idea of your data analysis chapter. That is what the data analysis plan will assist you. Even before you collect the data, as you outline your variables, then you go to the next step to say, how am I going to analyze them? What kind of variables am I collecting? And then you look at the different statistical tests that are applicable for the variables that you intend to collect. So it allows you to engage step by step. So it's not just a high level thing that you do, but it's a thorough engagement where you engage with all the pieces of information you're going to collect, and you are able to account. You think about it as in, I'm collecting this variable, level of education. How am I going to use it in my study? Do I intend to use it just to describe my population or describe my respondents, or do I want to use it for further analysis? So each variable that you will list, you will also then say, what is the purpose of the variable in your study, right? Which then says, what are you going to use the data for? How will it be analyzed? And in your mind, you can already have a picture of, as I say, your chapter for the data analysis. And you can go further and do tables, graphs that show and explain your outcome. So it will assist you to select the most appropriate. So even as you interrogate the variables, you are able to, you can also go back and reevaluate the methods, like the approach. Let's say you said you're gonna do a cross-sectional study, and when you look at the variables, maybe you will go back and decide, I actually need to um, do a study where I'm collecting data maybe at more than one point, maybe instead of a cross-sectional, or perhaps I need to do an experiment. So it will also assist you to refine what you'd already specified coming into that section. So what should it contain? Obviously, the research is all about the research questions. So the first thing that it must have, it should have the research questions. Obviously, you have the high level, and you have the ones that you've actually, the breakdown of the specific research questions. And if you have a hypothesis, you must list also the hypotheses that are associated with each. And to make it practical, or to bring it to your study and how you want to do your study, you need to look at the research questions and write them in terms of operationally, what do they capture. At that level, they are still questions, they are not yet variables, but even at a question level, you can expand to say, you'll see with an example, but to say in the context of your study, this is what you mean by that, by those particular questions. And then you need to give us the inclusion exclusion criteria, right? Which units are going to be included. It must have the variables. So you have the questions. From those questions, you'll be able to say, because this is my question. If, for example, if I go back to, okay, if I just pick up on the example I used yesterday, if you are doing a study to look at impact of exercise, how exercise impacts cardiovascular condition of university students. So you'll be looking at exercise, that you have exercise there. So you'll be looking at maybe you first, because the students are allocated in institutions of higher learning or in university, public universities in this case, you'll want to look at access, what kind of facilities are there. That one maybe can be something that you don't, it's not in the questionnaire, but it's some information that you collect from the universities. Then you'll have to look at the behavior, if they exercise, how often they exercise, which times they prefer to exercise, and all those kind of. So from that exercise keyword, you'll be able to expand and say, I want to look at what kind of facilities do they use to exercise, how often, the frequency, what kind of exercise do they engage in. Yeah, so that can be something that can emanate from that variable exercise, right? And obviously, you have the other keyword, which is cardiovascular. So even from there, you will now look at, in terms of that, what really do you want to zoom into? And I think you can hear, as I'm expanding, the variables are coming out, like frequency of exercise. And then you'll have to say, how are you going to measure it? That frequency of exercise. Access, how are you going to measure it? The types of exercises they participate in, how are you going to measure? So with each variable, then there's the how part, because we know that oftentimes variables can be measured in different ways. There are those variables that are just standard, but then there are variables where you as a researcher, there are several options in terms of the approach you can take. And so you list the variables that you want to collect, and you also list the variables that will be derived. So perhaps you're going to collect data on, maybe let's say you are doing something on employment, unemployment. So you're going to be able to get the employment status of your participants, right? You're able to say whether a person is employed, unemployed, and one of the variables that you will compute there will be their unemployment rate. So taking those who are employed or those who are unemployed divided by your total, the number of the total number of persons. So you'll also have to say, from these two variables, I'm going to compute the unemployment rate, and you give a definition. For example, we know that in South Africa we have the expanded definition, and we have the other one, where one of the one definition does not count people who are discouraged. So if they come and they ask you if you have gone out to look for work in they use a reference period. Maybe they say in the last 7 days or whatever reference period they use. If you say no, and you are actually eligible, you are not a student, you are not retired, and you are not sick, you are eligible to be employed, then they will count you as a discouraged work seeker, which means that you are no longer applying, sending out your CV, so you are discouraged. Then depending on the definition that will be used, you will either be counted or not counted. So those are some of the issues. Then very important, the role of each variable has to be outlined in your data analysis plan. The role is maybe, is it the variable of interest, the outcome? So for example, if I go back to my example of exercise and cardiovascular diseases, you want to know whether exercise, so exercise becomes the independent, and then you want to see how it influences cardiovascular. So you'll then have to explain that exercise and everything else that will be associated with exercise, and maybe other things that you will add, will play a role of factors or independent variables, and the cardiovascular, their status with regards to cardiovascular diseases, then will be the dependent. So you have to outline each variable that you're going to measure. You need to know what role it's going to play in your study, and then describe the scale of measurement. I will expand. You need your data analysis plan. If, for example, you are using secondary data, this is more applicable. If you are using secondary data, you will have to list that I'm going to be using a list of students from the University of South Africa, or I'm going to be using a list of data that contains companies that are registered for VAT, and then you need to now look at it's advised that you look at you get information on the data before you finally you actually finalize your plan of using it, so that you are aware of what it has and to what extent you can use it, right? So you need to take time to understand the data set, understand what was it primarily collected for, right? You have to look at the design to say in terms of the data, maybe it was collected for another study. What was the design of that particular study, or was it a census? How was the sample selected if it's data that was collected for another study? The format of the data also very important, because you don't have an unlimited access to softwares, because eventually this data you must bring it into your tools. So if, for example, the data it's in a format that you don't have the softwares to read that data, then you need to plan ahead. Some of the things, when you mention them, it's as if they don't happen, but they do happen. I've had a student who had requested data, which was kind of map data, requested it from Statistics South Africa. They gave the student the data, but the student couldn't read the data, those maps. She needed a software to actually be able to read the maps, which she didn't have at the time. And we'd actually been working on the study for a long time, spent a lot of time on the sampling plan. And when we got to the point where she requested the maps for her to go and do the pilot, then the maps came in a format that she didn't have the software. Fortunately, her employer, the study was related to her work, so the employer was supporting her. They could fund or whatever software was needed. So if you don't have that privilege, then you can see that it will just destabilize your entire plan. So you need to be aware of the format, who owns the data. If you need permission to use the data set, most data sets you need permission. There are those cases where you don't need permission. For example, if you are using data from Statistics South Africa, it's data that is available to the public. They just need to maybe tell you how you can download it, but you don't need permission. But in most cases, you do require permission if there are costs associated, and if the data is weighted, right? How many observations is there? Does it have enough observations for what I intend to do? Does it have the variables that I have conceptualized? How complete is the data? How recent? There is the issue of completeness and of it being timely, such that maybe the data is out of date. It's complete, but it doesn't talk to what is happening now. So you need to be aware of those dynamics. And if you have to supplement, can it be supplemented? Most importantly, get the metadata, the code book. If a questionnaire is being used, get the questionnaire so that you can see in what format. Then your data analysis plan must contain the methods. So your plan has to contain the methods. I'm here now. So you need to write out the methods that you're going to be using to analyze your data and the software. And then we also say you need to have the table shells, right? The table shells, it's like they actually are your chapter, your data analysis chapter without the numbers. So for you to be able to develop these tables, you need to have a good grasp on what you are doing, understand your variables, as we will go through how to look at your variables in the workshop. So you need to have shells. So even before you do data analysis, you can already have a table that the only thing that will be missing in the table will be the figures. But you actually know that I'm going to have a table like this one, and this table, this is what it captures. So let's just start with an example. So this example is what we will use for the data analysis plan. So this study was done by Mkhunu and the colleagues, and it's a 2012 study. They're looking at prevalence of adolescent pregnancy and associated factor in the South African context. So they used this came as part of a population-based, it was a household survey, right? Meaning they're collecting data from households, right? And the survey was part of evaluating the impact of the love life. So if I think you've lived long enough, you'll remember the Love Life campaign that used to be I think it was also even on TV, on our TV. So the study, part of the study was to evaluate its impact in terms of HIV prevention for young people. So the article itself didn't have specific objectives, but I from the article, I came up with these two specific objectives, which one was to look at the prevalence, right? I'm picking it up from here. So I always advise that you must highlight the keywords that are going to assist you to unpack the study in terms of use them to see what variables, because when you say prevalence, then you will look at what will go with prevalence. Adolescent pregnancy, even here you'll have to be clear in the context of your study and the South African context. Also, you need to, I'm highlighting it because you'll need to expand or give clarity on when you say the South African context for your study, what do you mean? And the other was to look at the factors, the risk factors associated with. So this will be your independent variables, right? So from here, you can you can write it in terms of operationally. So here, it's the proportion of young people who either fell pregnant. So you can see now when it is unpacked, at a face value, when you read this, you actually thinking it's a study that is looking only at females, right? But now when it was unpacked, you can see the study actually looks at both the males and the females to see whether these young people have whether they fell pregnant when they were teenagers or if they impregnated someone. So if you are a female, did you fall pregnant when you were in your teens? And if you are a male, did you impregnate someone? So you can see now where it's going and the factors here. Then you'll have to look at your literature to say what factors do you want to include in the study. You are the one who will give the study direction to say, there are so many factors you can actually look at. So you will have to say, for the purpose of the study, these are the factors. So I'm just going to show you the what they looked at. So I hope you can see. So this is a Word document. You can see started with the main objective, right? And then put the specific objectives which I've shown you. And then I added this context here just to say, to capture that part, to say this was part of a population-based, a household survey. And the context was, I've added it here. And then the inclusion criteria, the study was looking at young people. So you must have been between 18 to 24 years. So they go to their household, and once they are at the household, they interview people who are in this age group, 18 to 24 years. And the South African context that they spoke about is actually 4 provinces out of the 9 provinces. So they are listed here. And then the thing is showing everything, even what we have not covered. But the main variable, the main variable, the outcome is about pregnancy, right? And then you describe it. These things you write. So you're going to say, male are asked if they have impregnated someone. So this is, you are the one who arrived here to say, okay, this is pregnancy, it's adolescence. For me, adolescent, okay, I'm gonna look, it's 12 to 19 years. So that's how you are the one who should get to this point to say, okay, I'm looking at adolescents, how are they defined? What am I going to align with, right? And here it's also giving detail to say you must either have impregnated or you fell pregnant. Then it goes now into a list of the factors, the independent variables. So they said there are variables which are at an individual level. So they had a group of individual level. So one of the variables is your knowledge about contraceptives, to say maybe if you were not aware, maybe it will increase your risk of experiencing a pregnancy. You are at risk, right? It puts you at risk. And at an individual, there's also condom use or use of contraceptives, which, so for each variable that you list, very important, you must say how you are going to measure it. So for example, it's knowledge. They asked this participants 9 questions, right? And then where they ask them if you've heard about the pill, if you've heard about the IUD, the injectables, emergency contraceptives, and the people are responding yes or no. You see, yes or no. These details you need. So you can see contraceptive knowledge. When you go to your literature, you might find that there are different ways you can measure it. And you have to say, for this study, this is what you're going to write out here. For my study, I'm going to ask these questions. The response options are yes or no. And when I've asked them these 9 questions, what do I do? Because I want knowledge, right? I want knowledge. Then they say, they are added together. So you even say these items, when I've asked them, I'm going to add them together to obtain a score. So meaning I'm using them at the end, knowledge will just be a score. And then I'll just maybe go through some. So these are the factors. These are at individual level, right? Use of contraceptives, even there you list the questions you're going to ask, you're going to use to measure. And in this column, you need to also put your references, which it's going to make things easier to say, my approach was influenced by whatever. You can put a reference to say this approach, this is where you picked it up from this study. Or if it's not in any study, you can just maybe give context as to why you approached this variable this way. And the knowledge, as I've said, you put a reference to say, how did you get to measure contraceptive knowledge? Because you take into account that other people have measured it before. And when you deviate, you'll also give an explanation as to why are you doing it a different way to what has been done before. So you can see list a lot of questions, a lot of variables, as you can see. And then some of the variables are at a social, so they are social variables. So it's your social network, resources, peer pressure. And with each one, as I've said, you say how you're going to measure it. For example, this one, they say they ask two questions, like, I have a strong network of my family that supports me. Obviously here, it's just this one example that is showing. In your case, you'll have to list both questions if you are using two questions, and you write, these are the response options. It's 1, strongly agree, 4, strongly disagree. And then they say you add, right? And then once they've added, they say if you got a score between 2 to 5, you are regarded as having low social network. If you get a score between 6 to 7, you have medium, and 8, you have high social network. So with every variable, you tell us how you're going to measure it. And if you are using more than one question, how are you going to use both of them together? This way. Then there are also structural variables. So they broke them up here. Poverty, maybe there's a relationship between poverty and adolescent pregnancy. So even poverty, they also indicate how they are going to measure it. At the end, they will get an index, and some structural variables like if you have your education, access to condoms. So there is this other one, 4 items, relationship control. I think this one was not outlined, but there is one that I want to come back to, like this one. So you can see risk status and behavior. Here, there's quite a lot of questions. Obviously, this was a big study, but all the questions are listed. And to say how they are going to be measured, I want to come back to this one later on. Yeah, so you can see the list is quite long, right? And there are some background variables, and then stratification, also important. If there are stratification variables or grouping variables. So this is how they stratified. So I'll just go back to the slides now. So you list all the variables. So you saw the example, which are based on this specific objectives. They emanate from there. Then the next thing is for you to say, what is the scale of measurement of these variables? So you've seen the variables, it's a quality, it can be looked at a quality or quantity that varies, right? It can vary from one unit to another, and variables are made up of attributes. So we have broadly, we have two scales of measurement: categorical, which we also say it's qualitative scale. All variables can be measured through a numerical or a quantitative. For categorical or qualitative, the variable is either nominal or ordinal. On the other hand, when it's a number, quantitative, it can be interval or ratio. So just to, I hope I won't stay long here. So with categorical variables, it's important for you to be able to distinguish between the different types of variables, because data analysis techniques, they depend on the scale of measurement. They will be influenced by how the variable has been measured. So this becomes very important. It will assist you even when you don't know maybe much about the tests. What I always say is it assists you to exclude what is not relevant. So qualitative, it's those variables that are measured in terms of quality, in terms of quantity. So it's the things that we don't, when you've measured them, you don't get a number, but you get a type. So hair color, when you measure hair color, what you get, if you measure my hair color, you will get a type. If you measure the next person's hair color, you get a type. It's brown, it's blonde, it's pink, it's black. You get a type. So that will be a qualitative variable. The other way to think about it is it categorizes. It categorizes. So the variables that it's gonna put me in the category of those with black hair, and the people with brown hair, it's gonna put them in the category of those with brown. So those variables where you can categorize your units, then they are said to be qualitative or categorical. And very important, those variables are not numeric. They're not numbers, they are types. So you can't take my hair color and add the next person's hair color. So if I say my hair color is black, then you add all the black, you add all the brown, and you get an average, which is what usually happens. You can't do mathematical operations on qualitative variables. Once you can't do mathematical, it means you can't compute an average, because for you to get an average, you must add things up. So already in your mind, when the variable is qualitative, you will know that statistical tests that have to do with averages are not applicable for that variable, because that variable, you can't average it, you can add. So you will be counting 10 had brown hair, 15 had yellow, and so on and so on. On the other hand, when the variable is numerical, it means you can, when you've measured it, you come back with a number. So if you measure my height, what you get is a number that I'm 1.6. If you measure my weight, what you get is a number. If you measure my age in years, what you get is gonna be a number. So you can count, or you can weigh or measure these variables. So how they differ, these variables, they differ in terms of quantity, how much. So if you measure me, I'm gonna be weighing 60, and you measure the next person, they weigh 55. So we differ by the unit, maybe 5 kg. That's how we differ, me and the next person who is in the study. If you look at qualitative, me and the next person, we differ by type. I said brown, they said yellow. We differ by type. On the other hand, I say I'm 30, they say they are 40. We differ by quantity, a number. The difference can be quantified by a number. And one of the key features is that here we can't determine distances between the data elements. So for example, hair color, you can't determine the distance between my black hair color and the next person's blonde hair color. And when you move from blonde, if someone says they have blue hair, what's the distance between blonde and blue hair? Whereas with numerical, the distance can be determined. As you saw, if I say I'm 30, you say you are 40, we can determine that there is a 10-year difference there. If the next person say they are 35, there is a 5-year. So these two types can be further, they can be defined further in terms of, for example, for the qualitative, they can be nominal or ordinal. If it's nominal, it means it's a type that doesn't have order. So hair color, it doesn't have order. It's brown, yellow, black, there's no order. Ordinal, it's a type that has order. So if we talk about level of education, it's a type. Someone says, I have matric. The next person says, I have a 3-year qualification. The other person say they have a 4-year qualification. It's a type, but it's got order, because the one who said they have a 4-year qualification, their qualification, they are more educated than someone who said they just have a matric. So there is order. You can see the other examples there. When it comes to quantitative, the numerical, the variable can be continuous or it can be discrete. When it's things that we count, like how many people are attending today, it's a count. I can't say there are 20.5. I have to give a whole number and say there are 100, 500, a whole number. So that will be a discrete when you are giving how many, when you are counting things. And the continuous one, it's the ones that can take any value over some continuous scale, like weight. I can be 60.1, 60.125, depending on how the scale is calibrated to show how many decimals it can show, right? Mostly these ones can be presented in decimals. With a discrete, it's a whole number. How many kids do you have? It's going to be a whole number. You can't have a child. So those things where you can count and you have whole numbers, they are discrete. When you can have decimals, then they will be continuous. And finally, for the quantitative, we can also look at them further in terms of whether they are interval or they are ratio. For both of them, the distances between the data elements can be determined, as I've said. You can determine the distance between someone who's 30 and someone who is 40 years. And also in terms of temperature, if today is 15 degrees Celsius and another day is 20 degrees Celsius, you can determine the distance, right? That there was a difference of 5 degrees Celsius. And the other important feature here is that there is equal spacing. So when I move from 20 years to 30 years, and I move from 30 to 40, that gap of 10 years has got the same meaning. 20 to 30, there's a 10-year gap. 30 to 40, there's a 10-year gap. The interpretation is the same. Similarly, with a temperature as an example of an interval, 15 degrees to 20 degrees, there's a gap of 5 degrees Celsius. 5 degrees Celsius to 10 degrees Celsius, there's a gap of 5 degrees Celsius. So there is equal spacing. The difference between the two becomes that the interval does not have a true 0 point, while a ratio has a true 0 point. A true 0 point means that for a ratio, if the variable, the value, if I measure the variable and I get 0, it means that that's the actual attribute. It means the attribute does not exist. So if we look at age, if someone says we are measuring age in years and it comes back as 0, it means it's still a baby who hasn't turned a year. So they don't have years as yet. With interval, 0 doesn't mean that the attribute is not there. So 0 degrees Celsius doesn't mean that there is no temperature. 0 degrees Celsius means there is temperature. On the other hand, with ratio, when it's 0, if we ask how many people are attending and we get 0, it means there is no one who's attending. So it's 0. So it means the value, that attribute, it doesn't exist. It's giving a 0. On the other hand, 0 doesn't mean so. I think the other example we can look at can be pH level, right? Where 0 doesn't mean there is no pH. So I'm gonna ask Bronwyn that before we proceed, maybe we can try this exercise 0, just to see if this is one of the ones where there are many questions around it as to whether should we treat it as continuous or do we treat it as a categorical variable, this type of scaled variables. So if you just take into account the notes that I've put on the side, I'm gonna ask you to indicate in each case. So what you see here, it's the same variable, and then in one case it's coded. So we know that the variables can be coded, right? can be coded. We prefer to code because it's easier to work with the coded data. You'll also make less mistakes, especially if you are capturing for yourself. Instead of capturing strongly disagree, it's easier to capture 1-1. In the next instance, it's coded using letters A, B, C, D, E. That is your choice. You can actually code them this way. And the other one is coded, but it's using a different coding scheme, if you can see. So I just want you to indicate for each one what is the scale of measurement. You can, yeah, so this is the form that you need to complete to indicate your responses. I'll just give you a few minutes. It's 3 questions. So I'll just give you a few minutes for you to indicate your responses, and then we can go through it. Let me go into the form, and I've been struggling with my forms. Let's see. We'll be able to find the form. This exercise 1, exercise 2, exercise 3. Let me see. This is exercise 2. I'm looking for my exercise 0, which is the one that you are busy with. Let me search. It's giving you time to complete the exercise. Yeah, I'm struggling to find it. Let's look at recent. Okay, let me come here. Maybe I'll find it. There. Okay, no attempts as yet. Were you able to post it? You can also access it through the Snapchat. Scan the code, and you'll be able to complete the exercise here. So I'll give you maybe 2 more minutes to attempt to respond to the exercise. Exercise 0. Okay, I'll just, for the sake of time, I'm gonna go through the responses. So what you had to do here is the scale here. You need to just say whether the scale is qualitative or quantitative. So what you have to ask yourself, is this numeric or is this categories? And these are categories, because if we look at the attributes that we spoke about, for example, so if we remember, for quantitative variable, must be a number. The distances between the data elements can be determined. So we should be able to determine the distance between strongly disagree and disagree, the distance between disagree and neutral, the distance between strongly disagree and agree. That any distance we should be able to determine it. And they have to have the same interpretation, same meaning. So meaning the distance between strongly disagree and disagree, because it looks like you are moving the same, and the distance between disagree and neutral should be the same. But with this scale, you can't determine the distance between your data elements, and you can't really say that when you move from neutral to agree, you are moving the same amount as when you move from agree to strongly agree. If we use the hair color, if like I said, when you move, if I have brown and the other person has blonde or red, when I move from red to brown, or from red to black, the distance, is it the same? And does it have the same interpretation? So here it doesn't. So it's going to be a qualitative. And the same as here, because it's the same question, but it's coded differently. So the question doesn't change. It's just the coding. And if the question hasn't changed, the response options haven't changed, then the changing of the coding doesn't change the variable. The variable is qualitative because it is grouping you up in terms of your response options. Those who strongly disagree will come here, and so on and so on. Similarly, the last one, it's the same response options. However, it's just coded differently, which would then mean that it is a qualitative. Yeah. So I'm just going to proceed from there. So this is a summary. So we have nominal, ordinal. Nominal, it's a category, but it doesn't have order. You can rank. Ordinal, it's a category that you can rank. Cancer stage, it's a category. Others are in stage 1, others in stage 2, stage 3, stage 4. It's a category. So when you say I'm in stage 1, we are able to put together everyone who's in stage 1 and count them. Similarly with stage 2, but cancer stage we can rank. So we are able, so the order, the response options, they have meaning. If you are in stage 1, we can say you are in the early stages of cancer. And if you are in stage 4, you are in the advanced stage. So the order is meaningful. With a nominal, there is no meaning there. If you say my hair color is brown, the other one says red, we can't rank them. They are just categories that can be ranked, but ordinal they can. And interval and ratio, they are numbers. Obviously, because they are numbers, you can order, right? If I say I weigh 60, the next person weighs 7, you can rank, you can order both of them. The only difference between the two is that ratio has a true 0 point, which means that if that variable has a value of 0, it means the attribute does not exist. And with a ratio, we can multiply, we can divide. With an interval, we can only add and subtract. So with the ratio, we're able to say, if I'm 40, I'm twice as old as someone who is 20. So that's the multiplication, and we can divide. So, so we've looked at the scale. So you list the variables, then you are able to, obviously, when you list them, you put the references, you tell us how they are to be measured. This must be measured as a yes or no question, or this must be measured using 5 questions with the following response options. And once you've asked the 5 questions, this is what you must do with the 5 questions to get to the final value that we are looking at. You specify that and you put the references as I've said. Then the next column is to say whether the variable is that's the scale and then the role. So there are different roles they can assume. It can be a dependent, independent. Dependent is what you are interested in. So usually you are not it's not under your control, that variable. You are interested in it. Independent variable, it's the variables that you want to determine how they affect the dependent variable. So those will be your factors, your risk factors. Some, depending on the design of the study, they can be manipulated. So with this study, which is the study that we are using as an example, it's a cross-sectional study. So they just ask you, they ask you if you are aware of different kinds of contraceptives. They ask you if you've been infected, you've tested positive. So they are just asking you, there's no manipulation, you're just giving responses. But if in other studies, when independent variables can be manipulated, if it's an experiment, then you can manipulate the independent variable. Then we have confounding factors. So variables that maybe are not, so sometimes the use of covariates, independent, sometimes it can be confusing because different texts you'll find that they will say independent variable, they will refer to them also as covariates. But I think it's important, maybe you must stick to control variables. So these are confounding variables. There are variables that you are not really interested in, but you know that they have an influence on your outcome. So, for example, when you do something on weight loss, because you know that the different genders, in terms of how our bodies are, we will not respond the same way to whatever you give us, just because of how our bodies are, the metabolic rate. So even though you might not be interested in gender, you end up collecting it to make sure that whatever differences you are seeing, they are not because of gender. So gender is not there, it's just there to, we say, as a control variable, to make sure that the gender differences, we control for them. Let me put it that way. We control for the gender differences so that they don't influence the results. So we don't say there's a difference, whereas the difference is because of the gender, not maybe the treatment that you are giving the people. So let me just go back to the to our document and touch on the, oh, it's closed. Okay, let me just go back to the document before we proceed and just touch on them, the different scales there. So we spoke up until this part. So here, the variable type, it's where you will be explaining that it's an outcome or a dependent. And most of the variables in this study, they are the exposure or your independent variables. So this will be the dependent, the focus, which is whether you impregnated someone or whether you fell pregnant when you were an adolescent, right? And then you describe the scale here. So it's going to be a yes or no. A yes or no is a category. Others will go into the yes category. Others will fall into the no category. It's not a number, and it doesn't have order. we can't say the yes come first, the no come first. It doesn't have order. So it's a category that doesn't have order. We say it's nominal. If we go back to contraceptive knowledge, we were told that they will be asked 9 questions and a score will be computed from those 9 questions. So then it gives us, once we have a score, it's either you're gonna get either you're gonna get 0, 1, 2, 3. It's ratio, because if you get a 0, it means you have no knowledge at all. So it's a ratio, because 0 means you know nothing with regards to this, what is being asked. Then obviously you get a 1, 2, 3, 4, 5 will mean that's how much you know. And another one was contraceptive or condom use. Even here you are asked if you've accessed, if you've used any of this. Here is if you know, here it's use, right? If you've actually used this, any of this, then an index is also computed here. It's yes or no, then also because it's gonna be a ratio, because if you don't know, if you haven't used, then you're gonna get a 0, right? And then if you've used, then we will count. There's quite a lot of ratios. There is self-esteem. It's using this scale, 10-item Rosenberg. It's an existing scale that they're using to measure self-esteem. And they are explaining the questions. They are listed here. And it has to be scored. Once they've asked the 14 questions, how many questions? I can't remember. 10 questions. Then they compute. So from the 10 questions, they classify you. So the final variable is binary, which is it's nominal. So if your score is less than 15, you are classified as having low self-esteem. So you can see, you know your variables. You know, this is how I'm going to measure it, and this will be the scale, and you will see how it's going to assist us. I can go maybe to the bottom. I want to see something that is so for example, sexual attitude, they also ask 10 items, and at the end, from those items, they rate you whether you have low sexual permissive attitude, medium, or high. So that's going to be ordinal. It's still a category. It's either you are going to be in the low group, the medium group, or the high group, but it's got order, right? Those in the low group, they have low sexual, and so it's got order. Another one that maybe is it's one that is going to be ordinal. I wanted us to look at this one. So this one, it will depend on the responses that you get. This one and this one. It will depend on the responses that you get. So I've highlighted it to use it as an example. So let's maybe use this one. Number of pregnancies. They say, you see how very detailed you are to be. If you look at this number of pregnancies, including miscarried and terminated pregnancies, or pregnancies where the baby had died after, so they stillbirth. So when they say number of pregnancies, it's also very, very explicit to say what is included. So for example, if we look at this group and we look at number of pregnancies, maybe it's going to be, for those obviously who don't have kids, it's going to be 0. For others, it's going to be 1. Others, it's going to be 2. Remember, the participants, they are between 18 and 24. So you're not really expecting number of pregnancies, 7, 8, 9, 5. They are more likely going to be concentrated around your 1, your 0, your 2, right? I think it's fair to assume that not a lot of these participants are gonna have 3 maybe pregnancies or 4. Some will be there, but they will be kind of a concern where they are concentrated. So you might end up having to, even though they are giving you a number, you end up maybe having to categorize, where you have 0, which is a category for those who have they've indicated 0. You have 1, maybe for those who said 1, 2 for those who said 2. Maybe you say anything 3 and above, you put it together. So you end up having 4 categories, which now it's ordinal. So it was like it's a number, they're giving you a number, which is a discrete. But because the possible numbers that they're giving is not, like, it's not that wide because of this group. So you end up having a limited number of responses such that you can actually group them. And even though when it was asked, it was a discrete, but when you look at the responses in how you will deal with it, you will deal with it as categories. As I've said, you have 0, 1, 2, 3. And maybe you say you have 3 and above as the last category. I hope it makes sense. Oh, I mustn't close it so that when I want to come back, I can just come back. Yeah, so we looked at the role, we looked at the scale. So we've just looked at the role, and then you have your variables, you've defined what their role is, you've listed them, you've also specified how they will be measured and the scale in terms of whether it's going to be nominal, ordinal, it's going to be ratio, interval. So each variable there, you've also outlined what will be the scale of measurement. Then you say, okay, given these are my variables, given these are the roles, how am I going to analyze them? How can I analyze the variables that I have? So we are now at data analysis. When you analyze your data, the first part is to summarize or to describe. So when you analyze your data, the first part is you take all the responses, you summarize them, or we say you describe. So you have qualitative and quantitative data there. So you'll be summarizing that you are describing the attributes of your participants, because that's essentially what you are working with, those who responded. So we also say it's summary statistics. You want to present important or basic features of the data. So you can also do it graphically. And what will dictate how you're going to summarize it will be the scale of measurement. So your understanding of the different scales and what you can do with them, what you cannot do with them, will assist you to say, okay, these are my variables, this is the scale, then this is how I'm going to summarize. Then you are able to create the shell tables for the descriptives, as I will show. So in terms of how you summarize, if the variable is qualitative, then we count how many are in each category. So we're going to count how many said yes, how many said no, and we can compute a percentage. 50% said yes, 50% said no. We count how many, if we looked at the ones that had order, how many have low, I can't remember what was it, how many have medium, indicated medium, or when we were classifying fell into the medium category, how many fell into the last category. So that's a count, then a percentage. If the variable is a number like knowledge, contraceptive knowledge about contraceptions, we saw that it's going to be a score, and we said it's a ratio which means we can compute, we can summarize, we can add up the scores of the participants and get an average, or we can report a median or a mode. And if the variable has order and it's categorical, we can also accumulate. So if, for example, you'd collected data on age groups, not age in numbers, but age groups, then maybe in your reporting, you want to put a special emphasis on those who are young and those who are not young. So you can add up the groups, those who meet your young description. That's when you say you accumulate, you add up. You can add up and say this category and that category and that category, they constitute young people, and I can add up the account. And also, so that's cumulate means you can add up. You can only cumulate if the categorical variable is ordered. That's when you can cumulate. On the other hand, you can have more summary measures like variability to see how far this the observations are from the point of centrality. So here the workshop is not really to explain what is a mean, a standard deviation, but is more to say, if you have this kind of variable, this is how you can summarize it. Then you can go further. Obviously, there are other workshops where we look at what is an average, what is standard deviation, and so on. But when you prepare your plan, as you see that I need to use the mean, you can read further to say, okay, what is the mean? How do you compute it? But even when you don't know the details, you can still arrive at the right thing, because you know this variable is not a number. I'm not going to get a mean. I know this variable is let's say it's ethnicity. I'm not gonna add up people's different types of ethnicity groups. I'm going to be counting how many are in each group. So even though maybe I might not know, I might not be well versed with statistics, but I know that my variable is qualitative. And I know I'm going to be counting. I have 20 in this group, 30 in this group. Because I've counted and there's a total, I can compute a percentage. So I already know that no average for this one. It's a qualitative. So this is in terms of how you summarize them. I'm gonna go to the document again. Okay, okay, I thought it will remain open. So I'll have to go back to it to just show the shell tables. So you are doing the first part, we're done with the variables. Then you start with your data analysis. Now you talk about how you're going to summarize the variables. So you start to create shell tables. So this is where we are. So I've said that when we do our analysis, we start with the descriptives, right? So here are the descriptives. Then you maybe going to start with your qualitative variables. Then you know they are qualitative, I count. So this is, my summaries are going to look like this. I'm going to be counting those who said they are male. I'm going to be counting those who said they are female. I'll be counting. And then I can get a percent. So I can already see, okay, for the gender variable, this is what I'm gonna get. And you can even, the table can actually even have it can be final in the sense that it's got the right layout, the right colors. Obviously, at this point, it's not the most important thing. It's not whether it's red, brown, but it's for you to know what this variable is where it's gonna take you, this variable. But when you have time, you can even make it a final where you even give it the look that you want it to have. So all those variables that are quali, all our yes or no, unwanted pregnancy, if they've tested positive for an STI, you count those who said yes, those who said no, you get a percentage, right? Those who have reported their HIV, those who said they are HIV positive, those who said they are negative, those who didn't indicate, you count. Then you have, so this is how you can see, as I say, how your chapter is going to look out. Even at a planning phase, while you are still doing your proposal, you can already see the variables that maybe you don't need, and you can actually decide to remove them from your data collection instrument. Yeah, so this is an example. And then for the variables that are numeric, because they are numbers, then you will be able to say, okay, for these variables that are numeric, this is how I'm gonna present them. I'm gonna put the mean, the standard deviation, the median. I'm gonna show the maximum and the minimum. In your mind, you are very clear how you're going to use these variables. Okay. So you've summarized them. The next, so you've now outlined how you're going to summarize them by creating those shell tables. So you can see their tables, they have all the labels. They don't, the only thing that is not there, it's just the numbers because you haven't collected data, but you are definitely clear on what the variable is going to give you. You have a picture in your mind of when you have collected this variable, this is how it's going to look like in my chapter. And then the next level of analysis will be your inferential statistics, right? Here, I think I'm bringing this in back just to remind us that your study is about the population. So even though you are observing a sample, you always need to remember, unless you are doing a descriptive study, but it's about the population and you want to make inferences. So, which takes us to inferential statistics, which will be the next part of your analysis. So, because we are interested in the population, it's just important. The things that we observe from the population, we call them parameters. So, if I were to measure all the MNDs students, their age or their IQ, let's say IQ level, and get an average IQ for that population of MND students, it's going to be a parameter because I've measured the IQ levels of all MND students if they are APAM. But if I select a sample and I measure from the IQ levels of those I've selected, then what I have measured is a statistic which I am using to estimate the parameter. So the parameter is fixed, right? So if I measure everyone's IQ, it's if I measure it again, maybe the following day, it's most likely going to be the same. So it's fixed. But with a sample, with a statistic, it will vary from sample to sample. So it's dependent on the sample that you select. But it's just for you to remember that what we get from the population, it's we say it's parameters, and from the sample we talk about statistic. The statistics are used to estimate the population parameters. So when we are doing inferential statistics, we want to generalize. We want to make generalization about the population. So what we get from the sample, we want to generalize it on the population or make future prediction. We know that sample data is subject to variability. So in terms of your analysis for your inferential, you can have many, depending on the objectives of your study, you can have many levels of analysis. You can be doing your analysis at a univariate level, meaning you have some hypotheses that are around one variable. Then bivariate, it means your hypotheses are about relationships, and between two. Bi means two, uni means one. So here you might be having an hypothesis which is centered around one variable. Here you have an hypothesis that is centered around two variables. That's bivariate. You might have hypothesis centered around multiple variables. So like the study that we are using as an example, you have one dependent variable, but you have many factors or many independent variables. So there is one dependent, but several independent variables. So our study falls here. But when you analyze, sometimes you have more than one hypothesis. So in some studies, you might find that you actually have to do all the levels, right? This will be the highest level, but you find that your hypothesis, they dictate that you do, because you have a hypothesis on one of the variables, and you have hypothesis about the relationships, and also maybe about some variables and their effect on one. And if you have more than one independent, one or more independent and more than one. So these things, the way I've put them here, they are to assist you to say, okay, my analysis is about two variables, so it's a bivariate analysis. You might not know which test, but at least you know it's a bivariate. Here you know you have one dependent and several independent. You will know, okay, it's a multiple variable analysis. Here I've got more than one dependent and one or more, then it means I must do a multi. So even in my reading, maybe I have to look at multivariate tests. Here I have to look at bivariate tests, and so on. So in terms of multivariate, yeah, these are some of the examples. Maybe very, very more common factor analysis, very common structural equation modeling, very, very common these days, where you have construct variables and you have to look at relationship between your construct variables. So whenever you are working with construct variables, you maybe have to look at factor analysis and also look at structural equation modeling. As a high level, you might still have to do bivariate and some, but at a high level, consider structural equation modeling. So I'm gonna move into the guidelines, and then we'll just combine them with some practicals. So this is to help you. You will have the presentation to assist you. So you start to say, is my because you, as I say, you might have different kinds of analysis that you have to do. If you have an analysis where you have to look at, you have a hypothesis about one numerical variable, one quantitative variable. It's numerical, it's a number, meaning that we can compute an average. Here, you'll have to check whether there are certain assumptions are met or not, but at a proposal level, you can't. So you can say it's a one sample t-test. That's what you're gonna use. And when the data comes and you find that when you are analyzing, you are not able to meet certain assumptions, you will just change your analysis to a non-parametric one. But in your proposal, you can say that you will be using a one sample t-test. Whenever you see t-test, you must think averages. T-test averages. So these are tests that are for numeric. There must be a numeric variable. So when you see t-test, see averages, so that when you have qualitative variable, then you know that if it's one, you can't do a t-test. And then bivariate, if you have one numerical and one categorical. So bivariate will be two variables. So if, for example, the categorical has two groups, like yes or no, it's binary. Two groups mean it's binary or dichotomous. Then you can do a t-test because you have a numeric. So you can average this one and you want to see if there's a difference. So maybe you want to see if, yeah, so let's say, for example, there you had, we have knowledge, and you can look at knowledge against one of those yes or no questions there. That would give you an independent sample t-test. Or if, for example, you are giving, let's say you're giving your learners a new teaching approach. So some of your learners are being taught using this approach and others are taught using another approach. And maybe at the end they write a test. The test is going to be, they get a score, it's going to be a numeric, right? And then you have a category which 2 levels. One level is we use the standard approach. The other group, they were taught using a new approach. So you want to see if there's a difference. So you're going to compare the average score for those who were taught using a standard approach versus the score for those who. So similarly here, t-test averages. So it's the averages of these two groups. In this case, I used their class, their performance. So you can, in the proposal, you can say you are going to use an independent sample t-test, and we can always revise it when we do data analysis. So you can see the two groups in the example I gave, they are independent. So the learners who were taught using a standard teaching method, they are different to those who were taught, it's different units. With dependent, it's when it's still two groups, but the groups are dependent. So for example, when you do pre and post, so when you measure the learners before you give them an intervention, and you measure the same learners after you've given them an intervention. So then you are comparing the scores. You've got two groups. One group is before, another group is after, but it's the same people in the groups, so they are dependent, right? How I study and how I absorb information will influence me in the pre, and it will also so my personal influences will be there pre and post. So it's dependent data. So it's still two groups, but here we consider that there's dependency. So it's a t-test because it's two groups, but now this one was one sample. Independent sample t-test is when you have two groups. Paired t-test, it's when you have two groups, but the groups are dependent. On the one side, you have, it's still a bivariate. You have a numerical variable and you have a categorical. The difference here is that the categorical has more than 2 levels. So here we're using examples of yes and no, and that teaching approach and a new teaching approach. This side, you're going to have more than 2 groups. So maybe your interventions, you have a standard and you have 2 interventions. So one group, they are taught using a standard. One group, they are taught using method B. Another group, they are taught using method C. So you now have 3 groups. You no longer have 2, you have 3. So once you have more than 2 groups, then you can't use a t-test, you use a one-way analysis of variance. So if it's parameter, so for your proposal, you can go with one way. And as I've said, you can always revise to the non-parametric. So same as here, it's the same here. If you are collecting data, maybe it's about the study, it's about weight loss. So you are collecting data at more than 2 points, right? Because if it's 2 points, you can use a PET-T test because it's just going to be 0.1, 0.2, which gives you 2 groups. But if it's more, then you have to use a repeated measures, ANOVA. It's dependent because it's me, you are measuring me at the beginning, you are measuring me after month 1, after month 2, after month 4. I'm still the same person. It's just that you now have the 4 groups. It's my data, which in this case will be 4 time points. It's my data, so it's dependent. Yeah. So based on, maybe let's cover this before we, yes, so let me cover this one before we do the exercise. So you can also have a case where you have a hypothesis about a categorical variable. So you will see with the example. So here, a categorical variable, we said it's when we are looking at type. So yes or no. Prevalence is a categorical variable. If we go back to our example, whether they've impregnated someone or whether they fell pregnant, it's a yes or no. It's prevalence of teenage pregnancy as per the way it's been defined. So it will be one categorical. If you have a hypothesis about the prevalence, so if you had an hypothesis to say that there is some evidence to say this is the prevalence and you actually want to test that, then you will do a one sample t-test. If you had one of the objectives is to actually test the prevalence against some hypothesized value, then you do a one sample proportion. So here, when we talk categorical variables, we talk, when you say I have 20 out of 100 have brown hair, or 20 out of 100 said yes, it's a proportion. It's going to be 0.2. That's a proportion. Obviously, when we multiply it by 100, it becomes a percent. So whenever we talk categorical, we talk proportions which can be converted to percentages, which is the language that we are more familiar with, percentages. And if I'm doing a bivariate and I have a categorical and a categorical, they are not numeric. So there are no assumptions about that they are parametric. So they are non-parametric. So if it's 2 categorical variables, then you do a Pearson's chi-square test. If the categories are independent, you do a Pearson's chi-square test. And if they are dependent, then you will do the McNemar's test. I don't know if you'll remember, but let's do the exercise. Can I kindly ask you to complete exercise 1? So this data, it's data about mothers. It's got the attributes of the mothers. It's after birth, just after birth, newborn babies and their parents. So the baby will have an identifier. What is also captured is the length of the baby, their birth weight, the head circumference, the gestation, whether a mother smokes or not, the age of the mother, some attributes about the father, whether the baby had low birth weight or not, right? And there's also whether the mother is over 35 or not. So I'm just going to ask you for this exercise. All you have to do is to indicate the scale for these variables. All you have to do is indicate the scales for these variables. So I'm just going to ask you to access this exercise and indicate the scales. So it's not a lot of variables. I didn't put all the variables there, but so I'll give you 5 minutes to indicate the scale of measurement for the variables that I have put there in the exercise. So I'll just give us a few minutes to complete the exercise. Okay, maybe I can go and check. Maybe one of you maybe have that is exercise 1. That's the one that we are completing. Exercise 1 is this one. So you just have to indicate the scale of measurement for each of the variables. So we can wait up until 1940. There is one person who've responded. Thank you. Okay, I'll look at the responses now. So if we look at the length of the baby, yeah, I think it's fine to say it is ratio, even though I suppose we know length can have 0. But in this context, the baby can't have a 0 length, but in the true meaning of a variable length, it can have the weight of the baby. Yeah, it's the same as this one, whereby if the weight is 0, it means it's 0. So ratio would be correct. Gestation, which is how many weeks you have been pregnant. So for this, as a variable, it cannot, because it's either you are in week 1 of your pregnancy, or up until obviously maybe week 40, 41, 42 for those who go beyond the 40 weeks. So ratio is fine, even though it can't assume a 0 because you start from week 1, but it's got the other attributes of a ratio. Whether a mother smokes or not, so whether the mother is a smoker, a non-smoker, it's a category, but it doesn't have order. So it's nominal. It's like yes or no. You smoke, we can't order and say we order by maybe those who smoke, they rank 1, 2. There is no order. And the age in years for the mother, because the variable itself can have a 0, as we spoke when we talk about age, that if you say your age is 0, it means you haven't lived for a year. So ratio would be up. Then the number of cigarettes smoked per day by the mother, it's going to be, I suppose, yeah, it's discrete, it's ratio. It's discrete because it's a count, but it's a discrete that is ratio, right? Because someone can say 0, which means they didn't smoke. They don't smoke at all, so they can put 0 there, which makes it a ratio, because 0 means they don't smoke at all. So it's a discrete that is ratio scaled. So thank you for your participation. I hope the exercise they help. And then moving along, so from here, let's assume that, let's assume that you believe that smoking affects weight of newborn babies. So that's what you believe, and maybe you are a nurse who's working there, you want to do a study, so you collect the data, right, from the hospital. Here, you are looking at one group. We say it's one sample group because weight, your variable weight is numeric. So there is a t-test there. Weight is numeric, there's a t-test. You are looking at smoking, meaning now you want to collect data from the mothers who smoke, and you want to see, so from literature or your experience, you know that the normal average weight of babies at birth is 3.5. So you want to see if that's your hypothesis, right? So you want to see if the birth weight of this baby is born by the mothers who smoke. You want to see is so you're using this sample to see if I remember I said when our hypothesis, the null hypothesis, we usually state them in terms of the population parameters, because when you do a study, you are interested in population parameters. So we're saying the population parameter is 3.5. Then you're gonna take your data to see if the sample average from here differs significantly to this, whether you're gonna reject the null hypothesis or not. This is the average. Then you do a one sample t-test. Here, it's just to assist you to say it's one group. You're only looking at babies who are born by the mothers who smoke. It's one group, and you are looking at their average, the birth weight, which is a number. So you have a one sample t-test. One sample t-test, there will always be a hypothesized value that you are testing against. I think I've covered the. I've given context. Maybe we can look at this before we do So there are all other, obviously, other kinds of tests. I think the one that I want us to look at before we do the next exercise is, for example, if you have two numerical variables, so it's bivariate because you are looking at two variables and they are both quantitative numerical, then you're looking at a correlation between those variables. So you can do a Pearson's correlation, or depending on what you want to do, you can also do a simple linear regression. So in your proposal, when you're going to be looking at a correlation between two numeric variables, then you can say in terms of your statistics, you're going to be doing a Pearson's correlation. And if you're going to be doing, you want to do a model, then it's going to be simple linear regression. And let's stick to this side. If you have one dependent numeric variable, right? You have one dependent. Here, you have one dependent numeric variable. When it's a correlation, mostly it works whether you have a dependent or they don't have to have a role of being dependent, independent. You just looking at a correlation. But when you're doing a simple linear regression, one of them will have to be a dependent, one of them will have to be an independent. So because it's 1-1, it's easy. One is a dependent one. When you have one dependent that is numeric, and you have two or more numeric or a mixture of numeric and categorical, then you do a multiple linear regression. So your dependent is one, but on your right, in terms of your independent, you have several. They can be a mixture. They can be numeric. They can also be a mixture of numeric and categorical. And so they have to be either numeric, all numeric, or a mixture for it to be multiple linear regression. When you have one numerical and your dependent, they are all categorical, but it's more than one, then you will be doing this kind of ANOVAs, depending on the design. So if you have one numerical and two or more categoricals, then you will be doing this ANOVAs. Here you have one numeric, but your dependent, it's either they are all numerical or it's a mixture of numerical and categorical. Here it's one numeric and the other ones, they are all categorical. My cursor doesn't want to move now. Yeah, I've explained the chi-squared. And then maybe this last one to explain. If you have a categorical, which is a dependent, right? When the categorical is dependent, you have one plus your independent numerical and any number of categorical, like the example that we are looking at. Then the categorical will depend, the analysis will depend on the type of the categorical. So if the categorical has two levels, you'll be doing a regression binary because it's two levels. If it's got more than two groups, like where it had low, medium, high, it's going to be ordinal because there is order. And when it's more than two groups, but they don't have order, it will be multinomial. So here, what will influence, the right stays the same. It's this categorical that will influence whether it's a binary, whether it's nominal or ordinal. And then we also have this one when you have one categorical plus two numerical. Yeah, so we've done this one. I've shown you this one that we had. So the scale, the birth weight was interval, and we had a hypothesized value of 3.5. We were looking at mothers who smoke. So it was one group, one sample, mothers who smoke. It's numeric birth weight. So you do a one sample t-test, you can look at the average. These are the last exercises. Maybe before we do the exercise, let's finalize our I was not aware that it would close. Actually, maybe I must just open it from here. Oh, am I opening the wrong one? Maybe I must access it the way I was accessing it. Okay. Yeah, so we are here. So I've shown you the descriptives. Then we are now here. So we did the descriptives. I showed you the shell tables. Then you can have the shell tables now for your inferential, right? So here, if let's say you're gonna start with bivariate analysis, which is what you usually do before you do a regression. So if we come back here and we say that our outcome is, we have one outcome which is binary, yes or no, and we have several independent variables. So which means for our main analysis, we're going to be doing logistic regression. The dependent variable, it's categorical with 2 levels, it's binary. And then we have a mixture of several independent variables, the knowledge, quite a lot of them. Then we are doing a regression. But because our outcome is binary, it's logistic regression. If our outcome was ordinal, we would do ordinal. If our outcome was a nominal, but with more than 2 levels, we'll be doing a multinomial. So you will be doing some bivariate as a build-up to your logistic. So maybe you're going to do a 2-test to look at, you are comparing the knowledge, right, of those who said they fell pregnant or impregnated someone versus those who didn't. So does knowledge influence the behavior? Then you know the table, you already know, okay, because I have a variable contraceptive knowledge is ratio, I want to compare it for the 2 groups, it's 2 groups. So it's average knowledge for the 2 groups. So average knowledge is a t-test, 2 groups, 2 sample. So I know in my analysis, I'm gonna have a 2 sample independent t-test, and then you can do the shell table that when I've collected data, this is what I'm going to be getting and the rest. And I think it's repeating here. And you might also want to see, does the social network resources, is there a relationship between the pregnancy status and social network resources, which have been classified as whether they are low, medium, high. So social network resources is categorical. Pregnancy outcome, it's either you fell pregnant or you were impregnated, you didn't fall pregnant or you didn't impregnate. So it's binary, it's categorical. 2 categorical variables, I'm looking at a Pearson's chi-square test. So Pearson sky test, when I look, I can see that, okay, what you capture is the frequency, the percentage, and you get the test statistic and the p-value. In your mind, you already see where you are going. And then obviously there are other bivariate that you could be doing in between there. I just used these two as examples, but depending on the different variables, there will be other bivariate analysis that you will be doing, and you can put the shell tables. But in terms of your main analysis, I've already said your outcome is categorical with 2 levels. It's binary. You have many independent variables, so you are doing a regression because the dependent is binary. It's going to be binary logistic regression. And you can populate, you can go and look and see, oh, binary logistic regression, this is what it does. This is, you can read more further, and you can create the shell table because this is what is going to be. And then you can start to, so already at a planning stage, you have a view of where your variables are going to take you, and you can already maybe take out some of them because you see that they will not really add any value, or you can add because you can see a picture, you can even see what is not there because it's written. You know, when things are in your mind, sometimes you can't see what you are missing. Up until you write them down, you can see actually what you have and what you don't have, and you're able to fill in the gaps. So just to conclude, I think I just have, we can take the exercises as I go through the questions. So here I have some, we can start with exercise 2 and then do exercise 3 as I go through the questions in the chat. And we will just wrap up with by just discussing the responses to the 2 exercises. I think there is a link. The link has been put on the chat because I have to come back to look at the questions. So I have to move away from this screen. So to access the exercises, you can access them through the links, the form links that have been posted in the chat. Okay. So we can look at the questions. Not sure if they are down or up. Let's see. Okay, let's start here. Can I compare 2 sets of data for my research? So thank you for the question. Everything that you are doing is informed by your objectives. So obviously this is it's a workshop. So for example, for the case that I used to show how you do the data analysis plan, some of the tests I'm just bringing them in to show you. However, every test has to fit in with your objectives, and some of the tests are done as preliminary analysis, as a build up. So you can compare 2 sets of data. When you say 2 sets of data, it means you have 2 groups, right? I mean, if you have, for example, data for masters and data for PhDs, even if they came as different sets, for your study, they become one data. And then PhD masters become a group in the data. So you'll be comparing PhDs and master's students or doctoral students and master's students. So yes, you can compare. That one can use for data analysis. Yes, I mean, UNISA has SPSS for quantitative data analysis, and we also have Atlas TI for qualitative data analysis. So for if you are a UNISA student in your the where you specify the statistical software, you will say SPSS because that's what we have access to. And if you are doing qualitative, it's going to be Atlas TI. And if, let's say, you are doing things like structural equation modeling, it's going to be AMOS. That's what we have as a university. There are other tools, but if you are using the university tools, you're going to be limited to what I've mentioned. Actually, in other departments, they have other softwares for their students. So you can, if you want to use other things that we don't offer for the wider postgraduate student population, you can check with your department if the software that you want, they don't have it. Like there's also SaaS, there is MATLAB. So there are other tools, but those ones, then it means that you must have the skills to be able to use them yourselves, because in terms of the support is provided for the tools that are used by the broader university community. Yeah, I'm not sure because new tools, new methodologies, I suppose you need to be working with data for you to be able to stay up to date. You need to be working with data. And the thing is, yes, there are sometimes new softwares, but if you are someone who wants to work with data in the long term, maybe it will be important to learn things like R, because it's a free software and it tends to always have what you need. So even when there are new methods, you will find that in R, there is a package that you can use. Whereas with the other softwares, they tend maybe to lag a bit. But yeah, if you want to always be, R is one of the softwares that you can invest in. The only thing is that R is more programming based, as if you compare to SPSS, which is a point and click. You don't need to know how to code to use SPSS. That's why it's what we use most of the time. Yeah, so that would be my advice. I don't see any more questions. So I'll just close with the forms that we've just posted. The one is exercise 2. Okay. So for the exercise 2, so it's again the scale. Age in years will be a ratio. IQ score will also be a ratio. Anxiety, it's a category which is ordered, right? It's an ordered category. So it's ordinal. So it's none of the above. Can you sleep normally? It's a yes or no. So it's gonna be nominal. And weight will be a ratio. And if we look at the last one, which is it's on tests. So here you just needed to try and see if you will remember from the content. So you have two variables. One is life, it's binary, yes or no. And then you have another one that is depress, which is ordinal. So both of them are categorical. So if you want to look at a relationship between them, which will be an association because they are both categorical, then you can do a Pearson's sample. I'm supposed to be here. Then here you have IQ and age, and they are both numeric. So that's what is important here. The exercise is for you to be able to identify what is the scale of measurement of the variable. They are both numeric. Then you have to do, if you want to see the relationship between them, then it's going to be a correlation, and you can do a Pearson's correlation. Then there is life, which is a yes or no. It's a category, and weight. So we want to see life is, have you thought about ending your life? So if you've thought about committing suicide, do we find that there is a difference in the weight of those who've thought about committing suicide versus those who haven't? So it's two groups here. So we have a categorical variable, and we also have a numeric weight. So we see we can compute an average. So it's going to be some form of a t-test, because we've got two groups. Those who say yes are not the same people who will say no. It's independent. Then it's going to be independent samples t-test. The fourth one, it's so you've got this many variables, but the one that is dependent, it's amount of body fat. So you have amount of body fat, you have got tricep skin fold, tricep skin fold thickness, thigh circumference, mid-arm circumference. So, and you have one dependent. So you have one dependent that is numeric, and several other independent numeric variables. So it's going to be some form of a regression, because the dependent is numeric, then it's, and because you're independent, you've got more than one numeric, it's going to be a multiple linear regression. Then this one, it's about, have you thought about ending your life? And depression, thinking about ending your life, it's yes or no, it's categorical. This one is also categorical, two categoricals, it's a Pearson's chi-squared. So that's the end. And if you continue with the slides, it does have it's got the solutions for the, especially the ones on the test. The solutions are there, as you can see. You can go through them, and there are more guidelines to here to assist you to say which test can you lean towards. So there are more guidelines. So I'm going to pause here, and yeah, this is it. Thank you very much for joining us today. I hope you'll have a good evening further, and it's a goodbye from my side. Thank you.